This is the solving quadratic equations review. The first set, we are solving by factoring. With this method, we need to have everything on one side equal to 0, which means I need to move my 6 to the other side. And that gives me a squared plus 5a plus 6 equals 0. Now I'm going to go over to my little chart. The a squared is going to go here. The positive 6 goes here. And I multiply those together and I get 6a squared. What two things will multiply to give me 6a squared, but will add to give me 5a? And that's 2a and 3a. So I'm going to put my 2a and my 3a. And then I'm going to look and see what can I factor out of my rows. And out of my first row, I can factor out an a. Out of my second row, I can factor out a 3. And it was positive, so I factored out a positive 3a. So that means one of my factors over here is a plus 3. Now let's do the other factor. Out of my first column, I can get an a. Out of my second column, I can get a 2, and it was addition. So my second factor is a plus 2. And that's equal to 0. And so for that to be true, one of the two factors needs to equal 0. So I'm going to set each of the two factors equal to 0 and solve. And when I solve this, I subtract 3 from both sides, and I get a is equal to a negative 3. Now we're going to do the other one. A plus 2 equals 0, and I subtract 2 from both sides, and I get a is equal to a negative 2. And it's one or the other of these is the solution. I put them in the solution set, least to greatest, so negative 3, comma, negative 2. Now let's go on to the next one. Same idea. Only that's different this time is we have more we need to move around. We're going to subtract the 10 and subtract the 6x squared. And when I subtract those, I end up with x squared plus 8x minus 9 is equal to 0. Now I'm going to come over to my box. X squared goes in this corner. Negative 9 goes down here. So I want to know what two things will multiply to give me a negative 9x squared that will multiply to give me a positive 8x. And so that would be a positive 9x and a negative x. And so place them in my box. And let's do the rows first. I have an x that comes out of the first row and a negative 1 that comes out of the second. So I'll go ahead and write down my factor. X minus 1. Now let's do the second one. And I have, on the first column, I have a x, and the second one I have a positive 9. So x plus 9. And that's equal to 0. Just like last time, we're going to take those two factors, and we're going to set them equal to 0 each. So x minus 1 equals 0. I solve by adding 1. And so x was equal to a positive 1. Or I could have had x plus 9 equals 0. I subtract 9 from both sides. And x is equal to a negative 9. So my solution set, when I put them in order from least to greatest, is negative 9, comma 1. Let's go on to the next one. This next bit, it asks you to solve by taking the square roots, or by taking the roots. In this case, where we were taking square roots because the item that we're solving for is squared. So step 1 is to get your squared term by itself. So that means we need to subtract the 3. And that gives us the quantity of z plus 7 squared is equal to a negative 9. Now I'm going to take the square root of both sides. And remember, when I take the square root, that always gives us a plus or minus in front of whatever we take. And so we have z plus 7 is equal to plus or minus, well, the square root of 9 is 3. This I is going to come out as the negative is going to come out as an I. Now I need to get the z by itself, so I'm subtracting 7. There's not an I on that 7, so that means it has to be kept separate. So z is equal to negative 7, because we usually write in proper way of writing complex number. So we write the number first, and then the imaginary part. So that's the same thing as a set of negative 7 plus 3i, comma negative 7 minus 3i. And you could have written those in either order. Next thing we have, we need our square term by itself, but there is one on each side. And so we need to get it moved to where they are on the same side. I choose to always move mine to where it is going to be a positive a term. At the same time, you can move your constant to the other side. So I'm going to move 97 to the other side. And so I have 7k squared is equal to 656. Divide both sides by 7. Now find out that k squared is equal to a 108. And now I have my square term by itself. So I take the square root. And I find out that k squared is equal to plus or minus, and well, I need to see, is there anything that can come out of 108? Because 108, when I take the square root of it, is not a perfect square. So I need to look and see what I can simplify out. And so I take 108. And I know it's divisible by 2, leaving me 54, which is divisible by 2, leaving me 27, which is divisible by 3, leaving me 9, which is divisible by 3, giving me 3. And so I'm looking for sets. I have a set of 2's and a set of 3's. So 2 times 3. I don't have an I that came out because it was positive, but I do have the square root of 3 left behind. And so if I was just to simplify that out, I ended up with k squared is equal to plus or minus 6 on the square root of 3. So if I write my solution set out, not k squared, k is equal to, if I write my solution out, I have negative 6 times the square root of 3, and a positive 6 times the square root of 3 as my solution. Let's go on to the next one. Again, we're taking the roots, so we're trying to get the square term by itself first. So I'm going to add 7 to both sides. And I end up with 81 n squared is equal to a positive 16. Divide both sides by 81. And I have n squared is equal to 16 81st. Now I'll take the square root of both sides. And remember, every time I take a square root, I have a positive and negative for that solution. Square root of 16 is 4. Square root of 81 is 9. It was not negative, so there is no imaginary portion to this one. So my solution is negative 4 ninths, positive 4 ninths. This next one, add 16 to both sides. I have 3 halves is equal to x, or 3 halves x squared is equal to a positive 96. I'm going to divide both sides by 3 halves. And remember, when I'm dividing by a fraction, that is the same thing as multiplying by the reciprocal. Those will reduce, giving me a 32. 32 times 2 is 64. It's equal to x squared. I'm going to take the square root of both sides. Square root of 64 is 8. So a positive and negative 8. And so my solution is negative 8, comma, positive 8. This next set is where you have to tell me the discriminant and the number and nature of the solutions. On the test, I'm actually going to give you 4 of these instead of just 2. So step 1 is to get it to where everything's on the same side. So I need to subtract the 10 from both sides. Now, if I did this, I end up with a negative 8r squared minus 5r minus 6 equals 0. I personally do not like my a term to ever be negative. So I'm going to divide everything by negative 1 to change that. And so 8r squared plus 5r plus 6 is equal to 0. Now I'm going to identify my ABC. A is what is in front of my square term, in that case is 8. My B is what's in front of my variable, which is 5. And my C is a constant. And so I'm going to go back and I'm going to plug into the discriminant formula, which is b squared minus 4ac. So b is 5 minus 4 times 8 times 6. So that's 25 minus 192, which gives me negative 167. Because it's negative, that tells me that I have 2 imaginary solutions. So just a reminder, if I had a positive number, I would have 2 real solutions. If I have a negative number, I have 2 imaginary solutions. And if I have 0, I have 1 real solution. Let's do the next one. This time we need to subtract the 8. And we end up with 9b squared plus 10b is equal to 0. We are going to identify our ABC. A is what's in front of your squared term, 9. B is what's in front of your variable, 10. And C is your constant, 0. So we're going to plug into the formula. B squared minus 4ac. Again, we're just finding the discriminant in this case. So 10 squared minus 4 times 9 times 0. Well, anything times 0 is 0, so all of that's gone. 10 squared is 100. And so in this case, we have a positive number, and so we have two real solutions. And just to recap, you have, if it's positive, it's 2 real. If it's negative, it's 2 imaginary. If it's 0, it's 1 real. This next 6, and which on the test, I am only going to give you 4 that do this. You're going to solve using the quadratic formula. So step 1, everything to the same side. And I have 2v squared plus 5v plus 8 equals 0. Next thing is I'm going to identify my ABC. A, 2, B, 5, C, 8. Now I'm going to plug into the quadratic, or the discriminant formula, b squared minus 4ac. So 5 squared minus 4 times 2 times 8. So 25 minus 64, which is a negative 39. Now I'm going to look at 39. What can simplify out of 39? Divide it by 3 and end up with a 13. There's no sets, so there's nothing can come out besides my I. This is going to be negative because we're going to be taking the square root of that here in a second. So we're going to plug into the quadratic formula. In this case, our variable is b equals opposite b plus or minus the square root of b squared minus 4ac, all divided by 2a. So opposite b in this case, that's going to be a negative 5 plus or minus the square root of that negative 39 over 2 times a, so 2 times 2. So v is equal to negative 5 plus or minus I, because that negative is going to come out as an I, times the square root of 39 over 4. There is no number multiplied in front of my square root besides that I, so there's nothing can simplify. So my two solutions are negative 5 minus I square roots of 39 over 4, and negative 5 plus I square roots of 39 over 4. Going on to number 10. Number 10 already has everything on the same side. So we go straight to identifying ABC. So A is 8, B is 4, and C is negative 13. Go into our B squared minus 4AC. So 4 squared minus 4 times 8 times negative 13. That negative 13 is going to change that sign in the middle. Or if you're doing this with the calculator, you can all do it in one step. And that's 416. And that gives you 432. I know I'm going to have to simplify this in the square root here in a minute, so I might as well do it now. So 432, I know it's divisible by 2, which gives me 216, which is divisible by 2, which leaves me with 108, which leaves me, when I divide that by 2, I get 54, which when I divide that by 2, I end up with 27, I'm going to divide that by, I'm now out of 2s I can divide by, so I need to go to 3. End up with 9. I'm going to divide that by 3. I end up with 3. So I'm looking for my sets that can come out. I have a set of 2s, another set of 2s, a set of 3s. It was positive, so I don't have any i's that come out. So I'm going over to my quadratic formula. And in this case, n is my variable. Opposite b plus or minus the square root of b squared minus 4ac all over 2a. Opposite b is going to make this a negative 4 plus or minus the square root. You've already found that number is 432. All divided by 2 times a, which is 8. So negative 4 plus or minus, and we found when we simplified it out, we had 2 times 2 times 3 that came out. So 2 times 2 is 4, times 3 is 12. And what was left behind was the square root of 3. All divided by 2 times 8 is 16. So looking at the numbers, let's see if I can simplify with those 3 locations. They are all divisible by 4. So if I divide them all by 4, that's going to be a negative 1, 3, and a 4. And so my answer is n equals negative 1 plus or minus the square root, plus or minus 3 times the square root of 3, all divided by 4. And so my solution is negative 1 plus 3 square roots of 3 over 4, comma, negative 1 minus 3 square roots of 3 divided by 4. Number 11. Step 1 is to get everything to the same side, so I'm going to add the 5b squared, which is great because it's going to get me to where my b squared term is positive. And so that's going to give me 3b squared plus 6b minus 24 equals 0. And so I'm going to identify my ABC. A is 3, B is 6, and C is a negative 24. Plugging that into the b squared minus 4 AC, b squared, so that means 6 squared minus 4 times 3 times negative 24. In your Inspire calculator, you can type this all in one step. That gives you 36 minus a negative, we're going to come up with positive, 288, which gives us a 324. When I take the square root of 324, I come up with 18. Remember I said always take the square root first. That's the best first step to do. That way if it does come out to be a nice number, you're not having to spend the time working through simplifying it. And so b is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And so opposite b in this case is going to be negative 6 plus or minus the square root of 324, all divided by 2 times 6. Yes. 2 times 3, which is 6. Negative 6 plus or minus. Square root of 18 is 18. All divided by 6. Now, this is where the square root's gone, and so I'm going to take and find my two separate numbers. Negative 6 plus 18 divided by 6, and negative 6 minus 18 divided by 6. Negative 6 plus 18 is going to be 12. 12 divided by 6 is going to give me 2. And then negative 6 minus 18 is going to give me a negative 24. When I divide that by 6, I end up with a negative 4. So my solution in this one is a negative 4, comma, a positive 2. Going on to 12. 12, we need to get everything moved to one side again. And we end up with 3x squared minus 10 equals 0. So when I find my A, B, C, A is 3, B is 0, and C is negative 10. I'm going to plug this into the discriminant formula, b squared minus 4ac, and I end up with 0 squared minus 4 times 3 times negative 10. And so that's going to be a positive 120. I need to simplify the 120. I can divide it by 2, giving me 60. Divide that by 2, give me 30. Divide that by 2, giving me 15. Divide that by 3, giving me 5. And I have a set of 2's that can come out. And unfortunately, everything else has to stay inside the square root. And so x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So opposite b, in this case, well, opposite 0 is 0. Square root of 120, all divided by 2 times a, which in this case is 3. So x equals, well, 0 doesn't really matter. It can go away. We have plus or minus. 120 simplified to be a 2 that could come out. And what stayed behind was the square root of 30, all divided by 6. So this time, since the 0 is gone, I'm only looking at these two places to reduce. Make sure never reduce inside the square root. That is the one place that's never acceptable to reduce inside. And so we have x is equal to square root of 30 divided by 3, plus or minus. And so our two solutions are negative 30 square rooted divided by 3, and a positive 30 square rooted divided by 3. Last two that we're going to have to do the quadratic formula for, we have on number 13, we're going to subtract m from both sides and add 78. That's going to leave us with that 0 on that one side. And on our left side, we have 2m squared minus 32m plus 78 equals 0. Well, all of those numbers are divisible by 2, so I'm going to factor out a 2 out of all of those, giving me m squared minus 16m plus 39 is equal to 0. And so I need to identify my ABC. A is what's in front of your squared term. So A is equal to 1. B is equal to a negative 16. C is equal to a positive 39. Go into my discriminant formula, b squared minus 4ac. So I'm going to do negative 16 squared minus 4 times 1 times 39. And 16 squared is 256. Be careful on this. Make sure you're squaring negative 16 times negative 16. It will come out positive. Minus 156. And that's going to be 100. Well, I know the square root of 100 is 10. So I don't have to worry about simplifying using my division. So I'm going to go into the quadratic formula. M equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And so opposite b is going to be a positive 16. Plus or minus the square root of 100, all divided by 2 times a, which is, in this case, 1. And so m is equal to positive 16 plus or minus 10, all divided by 2. Our square root's gone, so that means I need to find my two numbers. 16 plus 10 divided by 2, and 16 minus 10 divided by 2. 16 plus 10 is 26 divided by 2, and that will give me a 13. 16 minus 10 is 6 divided by 2 gives me 3. And so my two numbers are 3 and 13. Number 14. I need to first get my everything moved to one side. And so in this case, I need to add a to both sides and subtract 28. So I subtract 28 from here and add a to here. A squared minus 10a minus 29 equals 0. Identify my ABC. A is equal to 1, B is equal to negative 10, and C is equal to negative 29. Plug it into the discriminant formula, b squared minus 4ac. So negative 10 squared minus 4 times 1 times negative 29. So 100 plus 116 gives me 216. And so when I simplify 216, 216 divided by 2 is 108. We've already done 108 a couple of times, but we'll go ahead and go through this process. 2 gives us 54. 2 gives us 27. 3 gives us 9. 3 gives us 3. I have a set of 2s and a set of 3s that can come out, leaving behind a 2 and a 3. And so I'm going to go over to my quadratic formula. And I have A is equal to negative B plus or minus the square root of b squared minus 4ac, all divided by 2a. And so opposite b, in this case, b is negative 10. So opposite b and negative 10 is a positive 10. Times the square root of 216 over 2 times a which is 1. And so the variable I'm solving for, which is a, is equal to 10 plus or minus. I had a 6 that came out because 2 times 3 came out, and a 6 that got left behind. All divided by 2. So looking at the 3 places I can simplify with, all of those are divisible by 2. Give me a 1, 3, and a 5. So my answer is a is equal to 5 plus or minus 3 square roots of 6. So if I was to write out in set form, 5 minus 3 square roots of 6, and 5 plus 3 square roots of 6. That's the last of the quadratic formula problems. The next set are just simplifying square roots, simplifying the quadratic formula after it's been plugged in. So on this next one, I need to simplify the 24. Divide it by 2, get 12. Divide it by 2, get 6. Divide it by 2, get 3. And I have a set of 2's that can come out. And so I have the negative 6 that's hanging out in front. It just drops down. I have the 2 that was brought out. And then I have the square root of 6 that was left behind. And so when I find that number, it's going to be negative 12 on the square root of 6. This next one, I'm going to take in the 288. I'm not worried about the negative sign. The negative sign is going to come out as an I. So I automatically know there's going to be an I in my answer. So 288 divided by 2, it's 144. I can divide that by 2 and get 72. Divide that by 2, get 36. Divide that by 2, and I get 18. Divide that by 2, and I get 9. Divide that by 3, and I get 3. So I'm looking for my sets. I have a set of 2's, another set of 2's, and a set of 3's. So 2 times 2 times 3 is going to give me 12. So 12 is on the outside in front of the I. And then I have the square root of what's left behind, which is 2. And so my final answer is 12i square roots of 2. Again, on this one, we have a negative, so it's going to come out as an I. That negative 7 is just going to drop down. I know there's an I involved, but I don't know what else, so let's find out. So 98 divisible by 2 gives me 49. Divisible by 7 gives me 7. So I have a 7 that came out as well. What was left behind is I have a set of 7's. And what was left behind is that square root of 2. So when I simplify this out, I get negative 49i on the square root of 2. One last one where you simplify the square root just like this. This negative sign comes out as an I. That 7 just gets brought down. I know there's an I. Let's find out what 54 has inside of it. 54, I can divide it by 2, and I get 27. Divide that by 3, gets 9. Divide that by 3, gives me 3. So I have a set of 3's that can come out. And I have a 6 left behind. And so I simplify that out, and I have 21i times the square root of 6. The next couple, these are going to be dealing with simplifying this I to a power. So when we're trying to figure out what I to the power represents, that's when I use that circle. And I can keep going around the circle and count by 4s and figure out where it is. Or I can divide my power. So I'm going to divide 82 by 4, and I want to find out my remainder. And so 4 will divide evenly into 8 twice. I subtract and I get and I drop down the 2. 4 divides evenly into 12 3 times. Excuse me, I don't know why I dropped down a 1. There should be a 1 that was dropped down. And it will go 0 times into 2. And so that means that I subtract 2. And then I get my remainder of 1. So if I come over here, a 2 tells me my answer is -1. So I take this -7 and I multiply it times -1, and I come up with a +7. Same thing's going to happen here as we did on this previous one. So we're going to take that 199, and I'm going to divide that by 4. 4 divides into 19 evenly 4 times. Subtract, and I get 3. 4 divides evenly into 39 9 times. And I subtract and I get a 3. So my remainder is 3. I come over to the circle. It tells me I'm at -I. So my answer is -I. This next one, first thing I'm going to do is simplify my square root. So 32 divided by 2 gives me 16. I can divide that by 2, gives 8. Divide that by 2 gives me 4. Divide that by 2 gives me 2. Look for my sets that can come out. I have a set of 2's, another set of 2's. And so I write down what I have. So -6 plus or minus 2 times 2 is 4. On the square root of 2, all divided by 10. And I'm going to look at my 3 spots that I can simplify with. And they are all divisible by 2. Give me a 5, a 2, and a 3. And so my answer is, and you don't have to write this in set form, it's going to be -3 plus or minus 2i on the square root of 2, all divided by 5. Because there's a square root in it, we don't have to go any further. We are done at that step. This next one, again, like I've said before, try taking the square root. This is one of the times where taking the square root was nice. It gave us a number. And so I have -5 plus or minus 15 divided by 4. And so I need to find the two different numbers, -5 plus 15 divided by 4, and -5 minus 15 divided by 4. So -5 plus 15 gives me 10, divided by 4 gives me 5/2, and -5 minus 15 gives me -20, divided by 4 gives me -5. So this time I have the set, because it didn't have the square root in it, so I need to write out the solutions. So -5, comma, 5/2, done. This next problem, 124 is not something I can take the square root of. So I need to divide, give me 62. And I'm going to divide that by 2, and gives me 31. 31 is prime. I have a set of 2's that came out, and the 31 got left behind. And so I have 4 plus or minus 2 square roots of 31 over 6. And simplify these 3 spots by dividing them all by 2. Gives me 2, 1, 3. And that gives me 2 plus or minus 1 on the square root of 31 divided by 3, which I don't need to write the 1. And so I'm done. I need to, on this one, I need to simplify the 32. The negative is going to come out as an I. The 32, I need to divide by 2. Gives me 16. Divided by 2 gives me 8. Divided by 2 gives me 4. Divided by 2 gives me 2. That tells me I have a set of 2's, another set of 2's to come out, as well as the I. Let's write down everything else. Negative 6 plus or minus, and we have 4 plus the I that came out on the square root of what was left behind, which was 2. And I'm going to divide that by 10. And so, looking here, I can simplify these 3 spots by dividing them all by 2. Give me a 2, a 3, excuse me, a negative 3, and a positive 5. And so my answer is negative 3 plus or minus 2i on the square root of 2, all divided by 5. Okay, this last one, we have a negative that's going to come out as an I. I need to simplify out the 180. I can't take the square root of it, so divide it by 2 gives me 90. Divide it by 2 gives me 45. Divide that by 3 gives me 15. Divide that by 3 gives me 5. So I have a set of 2's plus a set of 3's that can come out, and a 5 that is left behind. So I have 7 plus or minus 2 times 3 is 6 I on the square root of 5, all divided by 2. Well, the 7, the 6, and the 2 can't reduce, so I'm done.